Welcome, we're going to be doing Physics 220, lab number 4, the dielectric constants lab. For this lab, we have these two capacitor plates. This is the bottom plate, here's the top plate. We can lift and make a capacitor by putting them over each other. These are the dielectrics that we're going to be using here. I just selected two. This is the one labeled A and the one labeled E. Those are the two that we're going to be looking at. This is just going to act as a capacitance meter. So we can set this to this setting here, and this tells us the capacitance, and right now it's hooked between the plates, so it's close to 0 now, but if we move this on top, we get a positive capacitance number. And then we just got some calipers and tape measure to measure the dimensions, and we also have these little spacers, which they are the same material, same thickness, and material properties as the dielectric constants that we have over there. So we're going to build an air-filled capacitor using this, and our air-filled capacitor is going to have all the properties that our final capacitor will have, except of course the actual dielectric. All right, the first thing that we're going to want to do is measure the area of our capacitors, and so we just got to take measure here, and they're square capacitors. And so looks like we're about 49.8 maybe. That's centimeters, and just to verify, we still have about 49.8 on another one. So it's square, so you can find the area of each plate. The plates are the same dimensions, and so that's going to be the area of the capacitors for both capacitors. But let's go ahead and start looking at the first one that we're going to build. So the ID number 1 would be letter A, because that's what we're going to start with. And we have the spacers for letter A, and so we're just going to put them on capacitor plate, and what this is going to do, well actually first we should measure the thickness of these spacers, so I just have some calipers, 3.33 millimeters, and so we put these spacers down. Now I can put the top half of the capacitor on top. I'm going to make sure that it lines up. There we go. And so what we see here is that we have this capacitor that's just air in the middle, but the separation is such that it's the same separation as the width of the dielectric that we're going to stick in there in a little bit. And so there's our air-filled capacitor, and what we can do now is measure what it should be. And you should be able to predict first. So it says here calculated C1 air, and so you're using this equation here. You can look up these constants here. You know the area, well actually the K number is going to be 0 since it's just air, or sorry, it's going to be 1 since it's just air. And so we know the area, the diameter, can look up the permittivity of free space there and find what this should be. And now we're going to actually measure to verify what it actually is. And there's a measurement there, 0.876, is nano, so nanofarads is the scale here. So there's capacitor 1, just air. That's the capacitance of that. And so what we're going to do now is do the second capacitor. And so we'll take off these spacers. And this one is ID number 2, and it's going to be IDE. That's the ID for it. It's a little bit different material here, but we still have the same spacers that we're just putting down the exact same way. And we're going to need to measure the thickness again. So 2.74 millimeters is this one's thickness. And we can go ahead and build another air-filled capacitor. Sure that it's all lined up. Okay, so you should be able to calculate what the capacitance should be, and then that is the actual capacitance that we're measuring. And now we are going to move on to the dielectrics part, where we're going to insert the actual dielectric. Again, this is ID A, the material that's labeled as A, and we're just putting it inside the middle. You'll notice that the material sticks out a little bit from the capacitor plates, and that's okay because it's not going to affect anything outside the plates, at least not noticeably, appreciably, I guess. And then I am going to put this on, try to line up the plates like before. Okay. So here's our actual capacitor with the dielectric in the middle. So all the properties are the same as before, except we've, like in terms of the area and the separation between the plates, but instead we have inserted this dielectric, and so that kappa or K value here is no longer going to be 1. It's going to be some other value, and that's the ultimate goal that we're going to calculate here. And in order to do that, we need to write down the capacitance of the dielectric field capacitor. And so now that we have these two capacitances, the only thing that we changed in this formula is by adding this dielectric is this this K value, this kappa. And so what we can do is find the before capacitance and the after capacitance, and then solve these kind of system of two equations to find that value, and then that's what we're going to write down there. So pretty straightforward. That's it for dielectric A. Let's go ahead and move on to dielectric E and follow the same procedure. Just try to make them line up. Okay, should be good. All right, and there is our capacitance for this one.